Hello, my name is Ian Murray. I'm an associate professor in the Department of Physiology and Neuroscience at St. George's University. I'm also the program director for the Medical School Assessment Program. Today, we'll be talking about force-length relationships. And we'll primarily be doing this in skeletal muscle. And what we'll be discussing today are three different forces. The first is passive force, the force that the muscle generates when it's resisting being stretched. Second force, total isometric force. That's a total force that the muscle can generate at a specific length when it's stimulated to contract. So the passive force is without any muscle contraction, it's just resisting stretching. The total isometric force is the force that the muscle generates when it's stimulated to contract. The last force that we'll be talking about today is active force. All of these forces are measured on a specific apparatus shown here. This apparatus does two things. First, it's got a force transducer here that measures the force that the muscle generates. The second thing that this apparatus does is measure length change. And we'll write length here. So you suspend the muscle within this apparatus and you measure the amount of force that the muscle generates at a given length. And we'll just draw the muscle here in pink. So that's your isolated skeletal muscle. It's important to note that it's isolated. And what you're going to be doing in this experiment is you're going to be stretching the muscle to a specific length and measuring the force generated. And, very important, we're going to be locking this apparatus so that we only measure the force that the muscle generates at discrete lengths, at specific lengths. And that we'll plot on this graph here. Of course, it will be length on the x-axis, so that's the length that we stretch the muscle to, and this will be the force. The first force that we will describe is passive force. The passive force is the force that the muscle generates when it's resisting stretch. There's no active contraction here. There's no actin binding to the myosin. Okay, so this passive force is just the muscle resisting its being stretched at a certain length. And an analogy that we can have is like a rubber band. You have a rubber band and it's floppy at the specific length. So that rubber band will not generate any force. You stretch the rubber band a little bit more, and we'll use this as an analogy of the rubber band. You stretch the rubber band a little bit more, it's still floppy. There's no force being generated. At a certain length, a certain point at which you stretch that elastic band will start to resist stretch. That's what passive force is. So here, we stretch the muscle to a specific length. We lock the apparatus in place, we note the length, and we note the force. And the force will be 0 at that specific length. We stretch the muscle a little bit more by elongating the apparatus. We measure the force. Again, the force will be 0. We stretch the muscle again by sliding this apparatus down, and this elongation of pink represents the elongation of the muscle. And again, the force is 0. I'm just putting markers for myself. And the force is 0 until we hit a certain length where the muscle starts to resist that stretch and the force increases. So we can do that, and we stretch the muscle again and again and again. And what we have is we have 0 force here, and all of a sudden the muscle starts to generate force. That is termed passive force. An analogy is you take that piece of steak that you're putting on your barbecue grill, and you take that steak and you stretch it. That steak will resist your pulling on it, and you stretch it and stretch it and stretch it. That steak will resist, that muscle, skeletal muscle, will resist that stretch. The elements within the muscle that resist that stretch are the cells, as well as the collagen within the muscle, the endomysium, the epimysium, the perimysium. Those are the collagen constituents within that skeletal muscle that are resisting. There is no actin or myosin interaction involved in the passive force. That's because the muscle is at rest. So it's very important to note that with the passive force, the muscle is at rest. Therefore, there is no actin myosin interaction. So that's very important to know. These passive forces measured when the muscle is at rest. The second force that we're going to measure is the total isometric force. We use the same apparatus. We measure the force generated at different lengths of muscle, but we do something that's a little bit different. We stimulate the muscle here electrically or however you want, and we'll demonstrate that by this little lightning bolt. So we'll stimulate the muscle. We stretch the muscle to a certain length. We stimulate it, measure the total force, total isometric force. So the muscle is trapped within this apparatus at a specific length. When it contracts, the muscle doesn't shorten. It generates the total force that it can generate. That's why that's called the total isometric force. We stretch the muscle again, stimulate it, measure the total isometric force. And we do that again and again. Did I miss a point? And again. And what we find is that we've got a curve that looks like this. And this here is a total isometric force. So that's the total force that the muscle can generate. And I'm demonstrating that the passive force is down there. So that is the total force that the muscle can generate. For the observant student, what you'll notice is that this total isometric force is actually a combination of passive and total isometric force. Typically, when you're doing the experiment, you would stretch the muscle, measure the passive force, stimulate the muscle, measure the total isometric force. Why? Well, you only want to do the experiment one time for each replicate. Therefore, you don't want to have to stretch the muscle, do the passive force, stretch the muscle, do the isometric force, when you can stretch the muscle, measure the passive force first, stimulate it, measure the total isometric force. So we'll move on to active force. Active force is all of this space in between here. All of this is where active force occurs. All in between there, between the passive and the total isometric force lines. All of that is your active force. Why is it called active? That's because that's the force generated when you stimulate the muscle. That's the force only generated by the myosin and actin interaction. Whoops. That's the force generated by the myosin actin interaction. Passive force, there's no myosin actin interaction. Active force, myosin actin interaction. And that represents this whole area between the curve. Some of you students are asking, well, how is that represented diagrammatically? So this active force, as I mentioned before, is the total isometric force minus the passive force. So from this graph, what you can observe is that the total isometric force equals active force plus passive force. That can be rearranged such that active force is equal to total isometric force minus passive force. So that active force is this total isometric force minus the passive force. And you can actually represent that as a line on this graph here. So what you will do is you will subtract passive force from the total isometric force. And let's see which color I will pick. So here, the passive force is 0. The total isometric force here, you draw a point there, draw a point here, passive force is 0, passive force is 0, draw a point there. But at this point, the passive force starts to increase, so we'll subtract it from the total isometric force. So we'll draw a point here, and we subtract it from the top that way so we can actually draw the line on the same graph. We subtract that here, subtract that amount here, and subtract this amount from there. And what you'll notice is that you start getting a bell-shaped curve. And that is the active force demonstrated on this graph. So we've got 3 forces shown on this single graph demonstrating different force-length relationships for skeletal muscle. We have the total isometric force, we have the passive force, and we have the active force. It's very important to note that the passive force, there is no actin-myosin interacting. The muscle is at rest. Active force is when the myosin and actin interact with each other. So you have the thin filament or the actin here, and you'll have the myosin here. The myosin interacts with the actin to generate force. It pulls the muscle that way. That's the active force in between here. And the total isometric force is the sum of the passive and the active force. So we've generated force-length relationships indicating passive force, the muscle resisting, stretching at different lengths. Total isometric force, that's when you stimulate the muscle and you generate the total force, and then the active force. Thank you.